In this video, we're going to do a quick overview of the calculation questions from the UTM lab. You'll notice that you have your data table over here, and there's some crucial information that you need. For example, you'll need the concentration of the HCl used that was provided at UTM, as well as the total volume of HCl that you used during the lab. You'll also need your concentration of NaOH provided at UTM, and then also the volume of NaOH used during the lab. So let's go take a look at the questions. I won't give the answers away, but I'll give you kind of a general idea as how to proceed. So your first problem is not too bad. You just use the concentration of the HCl from UTM and the volume of HCl that you used to find the number of moles of HCl that was used altogether. Remember that the whole point was you had a flask like this, an Erlenmeyer flask, and inside you had some HCl. And that HCl is going to react with the CaCO3, which is the active ingredient from your antacid. So we're figuring out how much HCl did we put in here initially. And so you can use your C is equal to N over V, or some rearrangement of it, to find the number of moles. Now the next step is we did a titration. So we essentially took our solution over here and we did a titration to essentially figure out how many moles of the acid remain in here, because what's happening in here is the acid reacted with this CaCO3, which is the acid, the antacid. And so now we have less HCl, and we want to use this titration to figure out how much HCl we have left over. So let's go take a look at this over here. So this is our NaOH concentration. You use the concentration of NaOH and the volume of NaOH to find the number of moles of NaOH, again using the same idea here, C is equal to N over V. And the third part, there's a few parts to it. You have to subtract the number of moles of base used, so this, from the total number of moles of acid added. So let's say over here, the number of acid added was 5 moles. And then the number of base, the amount of base that you used, let's say it was 3 moles. What that means is that there were, you had 5 moles of acid, but when you did a titration, you only detected 3 moles of acid. So what does that mean? Well, that's the idea is that two must have been used up during the reaction with the base. So the first part here is subtracting. So you do your total amount of acid, which is 5, take away the total amount of base, 3, and you get 2. So you have 2 moles of HCl that has been that's left over, or that was used up, I should say, by the CaCO3. And so the idea is now that you know that the reaction that happened between HCl and CaCO3 was this reaction here. Something along these lines here. You can see the reaction written up here for you, like that. So you know that equation. And so if you know the number of moles of HCl, right here, 2 moles, you can use that to figure out the number of moles of CaCO3 that must have been in the sample that you used here. And essentially remember that that sample was for 0.02 grams of tablet. So you have to figure out from there how many moles or what mass you had in 1 gram of tablet, so per gram. And then from there, you can figure out, okay, well, how much is there in 1 whole tablet? So if you have the per gram and you know the mass of the tablet, you can figure out what there was in 1 whole tablet. So essentially, let's just say, for example, here you found you had 4 moles, right, of CaCO3 by stoichiometry. That's why we're telling you to pay attention to stoichiometry. You could figure out the mass of this, right? Because you know mass is equal to moles times molar mass. And then remember that this would be in I think it was, how many grams did they tell you to do? 0.2 grams? Let me go back and double check. If you forget about 0.2 grams, just make sure you write down what you weighed in 0.2 grams. Okay. So you found the mass in 0.2 grams. So you can find the mass in 1 gram by simply doing the mass in 0.2 grams divided by 0.2 grams. And so that will give you the mass per gram. And then if you know the mass of the tablet, you can just do the mass per gram times the mass of the tablet. And then that will give you essentially the mass of calcium carbonate within the tablet, within 1 tablet. Keep in mind that the mass in the tablet was in a smaller unit than grams. I believe it was milligrams. So you might have to do a conversion there and verify your work from there.